Hello and welcome to part 3 of the RRPP demonstrations. In this video I'll be covering tangent rings. If you missed out on part 1 and 2, please click the hyperlinks in the video. It would be good to go through these because they provide more explanation on how RRPP works and specifically the roles that RRPP switches have in the rings. With tangent rings you're really creating different RRPP domains. So this means that you can consider tangent rings to operate in an autonomous fashion. The switch that is connecting both rings has to be aware of the different rings. So the way to achieve this is to use a different RRPP domain for each ring on the intersecting switch. In each domain you can create the rings independently from each other. One of the things in creating different RRPP domains is that you have to assign different control VLANs to each domain. This means that if you would have two domains, you are sacrificing 4 VLANs, 2 for each domain. So why 2 VLANs? Well, the primary control VLAN is responsible of transmitting the RRPP PDUs of the primary ring, any HLO messages of optional subrings, and then the secondary control VLAN transmits the RRPP PDUs of the subrings. So this allows the RRPP control plane to distinguish between the primary ring and the subring PDUs. Really, other than that, there is no difference in configuring RRPP for tangent rings compared to configuring a single ring RRPP. You just have to configure an additional domain and create the ring in that second domain. In part 1 I've shown you the configuration of a single ring. So in this video I will only show you how to configure the tangent ring. There are no changes to the single ring configuration, so check out part 1 for that configuration. First, let me show you that the ring in domain 1 is operational by issuing the display RRPP verbose command. Verbose domain 1. You can see it's up, node mode master, and the ring state is complete. And now moving on to the tangent switch. So what I'm going to do now is I'm going to configure this tangent transit switch here. It's already operating in the on the main ring on domain 1, so I only need to configure the second ring. So let's get started here. So I will be configuring a second domain and create a new ring in that domain. And before we do that, we have to prepare the physical ports. We have to set them as trunk port, allowing the VLAN and disable spanning tree. So let's do that first. I'm using port 5 and 6 as you can see in the diagram. So interface gig 105, 05, port link type trunk. And I'm going to permit VLAN 10. And I'm going to disable spanning tree. And I'm going to do the same for port 6. Set it to trunk, permit the VLAN, and disable spanning tree. The other thing I'm going to do is I'm going to shut down the port just to prevent loops to occur. And now for creating the RRPP domain. So we're going to create a new domain. And what we have to do is we have to set the control VLAN. I'm going to use VLAN 4090. So we're now using VLAN 4090 and 4091 as control VLANs. I'm going to set the protected VLAN reference 0. And I'm going to create the ring. So it's ring 1, node mode. It's a transit mode. Primary port will be, let's check the diagram, 105 and the secondary 106. So gig 1/0/5 and then the secondary gig 1/0/6, and it's going to be a level 1. It's going to be a main ring. It's not a sub ring, so the level is 0. And enable the ring. Ring 1 enable. And that's it for the tangent switch. Now for the master switch. What we're going to do is master ring 2 here. So we're here on the master switch. Let's put it down. So what we're going to do for the master switch is we have to prepare the ports as well. I've already done this, so let's move on to the RRPP configuration. We're going to create an RRPP domain 2, setting the control VLAN, obviously, control VLAN 4090, and the protected reference 0, and let's create the ring. So this is going to be the master. So let's check at the primary and secondary port here. Primary is gig 102 and the secondary is gig 101. So ring 1 node mode master, primary port gig 102 and the secondary port will be gig 101 and again level 0. Ring 1 enable, and that's it for the master. Obviously we have a ring failure, and that's what you see here in the log. And then we have to do for the same for the other transit switch. So I already have prepared the physical port settings, so setting to trunk and disable spinning tree and allowing the VLAN. So we only have to create the RRPP domain. So we only have to do the RRPP configuration here. Control VLAN 4090, protected VLAN reference 0, and then we say ring 1 node mode transit. Let's check out the ports. So 102 is the primary, 101 is the secondary. Primary gig 102, secondary gig 101, level 0, and ring 1 enable. And then finally what we have to do, obviously, in order to make the ring work, is we have to unshut the port on the tangent ring. So if I remember correctly, this was interface gig 106, and we do undo shut, and that's all. And if we now check the master of this ring, you can see now that the ring is complete in domain 2. So if we do display RRPP verbose domain 2, you can see that the ring is complete, and you can see the control VLANs here, and so the rings are working now. So I fired up some hosts, 3 hosts from the diagram. Let me just show you the host. So this would be host number 1 with IP address 192.168.110, and I've got a second one here on top, which is host 3, which has 192.168.111, and then I've got the third one here below, which is 192.168.112. So let me just issue a ping to each of the hosts. So I'm just doing this in a loop, so you can see that this is all working. So what I want to do now is I want to shut down a link. I want to basically fail ring 2. So what I'm going to do is I'm going to shut down a gigabit interface 106 on the tangent switch. So let me just go to the tangent switch here and shut down. So you can see there's nothing happening here. And let me just move to the master switch, master ring 2, and you can see that there is a ring failure here. So if I do a display RRPP verbose domain 2, you can see that the ring state is set to failed, and there are no failures. So there's really very fast conversions on the RRPP ring when there's a failure. So there you go. It's all working and not too difficult to set up. This concludes the RRPP video demonstration series, and I hope you have enjoyed watching and found it very useful. If you have any comments or if you want to like this video, please do so, and have a great day.